Good afternoon, and welcome to IMA's Inside Talk Tech Talk Mondays webinar series. The title of today's presentation is Data Science in Accounting, Foundational Skills in Modern Analytics, sponsored by Oracle NetSuite. I'm Margaret Lockery, and I'll be your host for today's Tech Talk Mondays webinar. IMA would like to welcome Oracle NetSuite as the new 2018-2019 title sponsor for Tech Talk webinars. For more than 20 years, Oracle NetSuite has helped organizations grow, scale, and adapt to change. NetSuite provides a suite of cloud-based applications, which includes financials, enterprise resource planning, HR, professional services automation, and omni-channel commerce, used by more than 40,000 organizations and subsidiaries in 199 countries and territories. NetSuite has been a supportive partner of IMA for 9 years, and they pride themselves in meeting the evolving business requirements of companies of all sizes and every stage of growth. We appreciate them for their partnership and ongoing support. For more information, please visit www.netsuite.com. It's a pleasure to have Barry Nathan a part of our program, and he will be serving as moderator for today's event. For the last 18 years, until his retirement last year, Barry has been the fiscal manager of the Oregon Department of Transportation Information Systems. His previous experience includes TDK Corporation in the Spindle Motor and Read-Write Head Division. Barry is a member of the Portland, Oregon chapter of IMA. He has served IMA in many different capacities, including the Global Board for 6 years, from 2008 to 2014, as president of the Pacific Northwest Council for 4 years, and as chairman of the Pacific Northwest Council and Golden West Council REST events. He is also a member of IMA's Technical Standards and Practices Committee, working to understand how new technology will change organizations and especially the role of the management accountant. Barry earned an MM degree from the Atkins Graduate School of Management at Willamette University. He is a CMA, a certified IT financial controller, a member of the IT Financial Management Association as well. He has a passion for soccer and has spent 32 years as a soccer referee. Hi, Barry. Welcome to the program.
Thank you, Margaret. I am pleased to be part of the IMA webinar series, and on behalf of the IMA, I want to welcome everyone to today's session. At this time, I would like to introduce our featured presenter for today's program. With us today, we have Daniel Smith, solutions architect, innovation champion, data scientist, whatever people want to call him. Daniel's only real job is to help people and businesses grow. While Daniel has led big data science and distributed data initiatives for top names in oil and gas, insurance, banking, government, manufacturing, advertising, you name it, he's still an accountant at heart. Though he elected not to renew his CPA a few years ago, he remains a CMA and active with the IMA for over a decade because he knows accountants are central to the next generation of digital business solutions and wants to do everything he can to help them. Please join me in welcoming Daniel Smith.
Thank you, Barry. It is a pleasure to be here, and I'm so excited to have this conversation.
Before turning the presentation over to our speaker, I'd like to go over the learning objectives for today's program. After participating in this webinar, you will be able to describe how data moves and is stored within an organization. You will also be able to recognize foundational data and analysis techniques used by data scientists. You should know how to determine which of your day-to-day activities could be made better by data science skills and outline a training program if needed. And finally, you will be able to give examples of how effective data governance can enable data science. We're looking forward to an informative presentation. So at this time, I'm going to turn it over to Daniel to begin.
All right. Thank you so much, Barry. And thank you, everyone, for attending this webinar today. Today, I'll be covering some of the day-to-day activities of a data scientist. And before I get started, I do want to manage your expectations a little. Just give you a few things to keep in mind while you listen. First, don't expect to be a data scientist after watching this webinar. It probably took you years to fully understand accounting concepts, so don't be frustrated if something doesn't click right away in this presentation. Our objective today is have you recognize data science techniques and the opportunities to use them. This gives you a foundation for further study. What will help you in better identifying those opportunities is to consider your own situation as I'm describing these concepts. While I will be giving some examples, everyone has unique experience, and I cannot cover every possible situation. Feel free to ask a question in the Q&A panel if you can continue to struggle with how these concepts can help you. I don't want to leave you disappointed. And don't worry too much about memorizing every single concept. Again, this recording will be made available, and I also encourage you to take screenshots and plenty of notes as well. Now, with that expectation management out of the way, what exactly are these concepts and why do I think they can help you? The bulk of data science work is data, not science. Did you know that over 70% of a data scientist's time is spent just dealing with data? Data scientists would love for this to change, and later we'll discuss ways accountants can help make that happen. But given the current reality, data scientists have a lot of tools to clean and shape data, something that accountants can do a lot of as well. However, data scientists approach their data management differently than many accountants do. I've seen data scientists want to connect directly to the source of data, or at least the raw, untransformed source. This is because they have to frequently update their analysis, so they connect their analytics processes directly to the source data, oftentimes allowing automated updates without any additional involvement. In order to have that automation, they typically use coded scripts instead of applications. Coded operations are more transparent as we can follow exactly what's happening to the data, and more portable, meaning we can reuse the same code in similar situations, and we can easily find advice online from sites like Stack Overflow. Next point, here's the part you probably think the most about data science. They use statistics and machine learning to solve a whole host of business problems. Much more on that later. And finally, why am I including data governance in a presentation about data science? Remember that 70% of data cleaning that data scientists feel they shouldn't be doing? Bad data is the cause. And bad data is solved by data governance. This means data science can be over 3 times more efficient in a well-governed data environment, as in they are currently only at 30% efficiency. In fact, in a fully governed environment, they will happily automate every solution, making things even more efficient. Imagine the organizational benefit of automated models and super efficient data scientists. The cost savings alone is staggering. And we all need sound data governance. As you might not know it yet, but accountants are very, very good at data governance. I'll be teaching you some basic examples, acceptance criteria, testing, version control, file validation. This should get you started, but I hope during the presentation you also consider how important good data is to everything else working well, and how important the skills of accounting can be in establishing quality data governance practice. Well, now I hope you're suitably inspired, or at least listening a little more. So on to our first objective, describing how data is created, stored, and moves in an organization. First, we're going to look at data creation and storage. And I'll start way back in 1967, when Dr. Melvin Conway identified that any system designed by an organization will match the communication structures of that organization. What that means in plain English is that a business will create processes and solutions based around how they are structured. Marketing, supply chain, accounting, they'll all produce their own applications and typically their own data as well. And who were the first people to start storing and recording data? All the way back in Sumeria, the accountants. In fact, I would argue that our current data architecture is largely founded on accounting practices. Accountants use transactional data created by customers and business operations to produce reports that are then used to inform stakeholder decisions. So what does this look like? Well, there's 3 primary domains: business data, the creation, storage of data, and the business decisions. Now, where does this data live? Well, the customer activity generates transactional or raw data. That data is stored in a transactional database, which is then shaped into a reporting data set. The reporting data is used to make business decisions, and the resulting activity from the business decisions create more transactional data. Now that we've seen how that data is created, let's look at how it gets from one place to another. You can see the data movement cycle over here on the right of your slide. When that data is first created, the information messages are typically transferred through a bunch of layers and applications. So load balancers, temporary caches, firewalls, etc. The process of getting activity data into your data system is typically called integration, and it moves data into a transactional data store. Now, once it's in its raw form, or sometimes as part of integration, the data is shaped or cleaned into a form usable by people in analytic applications. This is generally called ETL, extract, transform, load, and the data output is stored in the reporting database, data warehouse, or data lake. The transformational of data into business usable information is called analytics. We will talk about a lot about this in the next module, although, like I said, simply put, analytics is what facilitates data-informed decision-making. And finally, business decisions attempt to influence customer activity. Making this one little arrow right here, influencers, in the upper left-hand corner of the business data creation and movement cycle, the entire reason that business exists and the entire reason that the data analytics cycle exists to help the business make more informed business decisions. So let's look at this process in action. Oops. There we go. All right. So first, we'll use a scenario of an insurance provider who accepts online applications for new policies. First, the customer enters their data into the online application. As they enter data, it's immediately added to a CRM, Customer Relationship Management database, because we still want a record of every application, as well as the customer information or potential customer application. Now, once they submit, it goes into a risk evaluation model to identify the customer as high risk or not high risk. If they are not high risk, they're moved to the purchase approval process where they enter in their information and then charged and added to an ERP. If they are identified as high risk, then they're moved to a manual underwriting agent that does a little further review and diligence on the customer and may manually approve them, at which point their information is also added to the ERP. Now, to do analysis on this, we can combine the CRM and ERP data into some sort of enterprise data warehouse, EDW. And an analyst can look at models or do evaluation on the customer behavior, etc., and generate reports that can be used to help make business decisions. One of those business decisions by the business user may be that they need to update the model, and at which point the analyst or data scientist would create new acceptance criteria or new business rules around what is or is not a high-risk individual or high-risk customer. And with that deluge of information, it is now time for our first polling question. Barry, take it away.
Thank you very much. Attendees should see the first polling question now open on your screen. I would like to remind all participants that you will have about 30 seconds to respond to each of the polling questions today. You may begin responding to each question as soon as it appears on your screen. Our first polling question is, how does your department primarily store and share data? A, data lake / big data. B, NoSQL document database. C, relational database SQL ERP. D, shared drive. Or E, email. Please note that after selecting an answer, you must click the Submit button, which is located on the right side of your screen, just below the response option, in order to successfully record your answer. Now I'm going to turn the presentation back to Daniel.
Sure thing, Barry, although the first thing that I'm going to do is I'd be interested in knowing back in your day, I know you're retired now, what was the primary way of storing and sharing data for your organization?
We did ours through a data warehouse. We had an IBM data warehouse product that we used, and that provided us with quite a bit of how we would store the data and how we would utilize it.
Very cool, very cool. I've seen a whole bunch of different organizations, so I've seen them all. But let's take a look at what our results are now. It's been about 30 seconds. Again, if you were unable to answer in time, please post something in the QA. And it looks like the bulk of people were almost equally interesting. It was between a relational database and a shared drive, and a few popping up on data lake and email. Barry, you have any thoughts on these results?
I'm not so sure that I'm looking at it. Well, I'm glad that the email is less than 5% because that's probably the least efficient way to store data and also the least secure. But, you know, the shared drive and the relational database, about even on those, and that's kind of what I would expect, especially for our small and medium business and enterprises.
Yeah, exactly. And as we're seeing the price come down on big data, I'm actually impressed to see that at 10%. There's a lot of ways that you can do that more affordably now, though, so it's not as surprising as it may seem. But yeah, so on to the presentation. So since we have some big data folks in the audience, this will be even more fun. Let's talk about recognizing fundamental data science and analysis techniques. And to kick things off, we will use the classic data science slide. What is data science? And as many of you have probably seen before, data science is the intersection of, first bullet, statistics and analytics. That is the use of statistics, mathematics, and research principles to create information from data. Our second bullet there is data and data applications, understanding the data structure, transformations, and programming applications to manipulate data, and business domain, how to apply information created from analysis of data to benefit business, and how to recognize how data and analytics may be best used to solve business problems. All right, so how is data science currently helping business? Well, data science is actually the current solution for accelerating this business cycle we talked about. To achieve this, they use their skill domains to aid in the creation and movement of data. Right? They accelerate business decisions through classifying data into more understandable groups, like clustering or predicting outcomes. And to better communicate the results, they use visualizations to distill complex results into meaningful information. To perform this analysis, they use data and data applications. They connect these applications or code to data to ensure timeliness, clean and filter to make sure data is accurate and relevant, and then shape the data through combining different sets, joining or merging, and performing various types of aggregations, sum, average, dividing by mean, etc. And of course, they assist in the correct interpretation of their analysis. Now for this presentation, I'm concentrating on data and analytics as the business domain application is specific to, well, your business domain. I can't give everyone relevant examples for all their businesses, but I hope I can show some foundational concepts to help get you started about learning a little more. Right? And let's look at these fundamental steps that I talked about. In order to get data to the point of making it relevant for business decisions, we're going to review the general progression of connecting, cleaning, shaping, and analyzing data, and introduce some of the techniques used during each step. I'll speak more in depth to these steps in later slides. This is just to introduce the concepts and show how they all work together. So first, here on the left, is our connection to data. And our primary sources of data are databases, online data sources, and raw data files. Connecting to these sources, we're using JDBC, ODBC protocol, APIs, and read operations, respectively. Following our next polling question, we'll speak more in depth on these, so I'm just going to jump right into the cleaning phase, because that's where we, clean our data. This is the process of making sure our data conforms to our defined requirements of quality, consistency, and representational faithfulness. To accomplish this, we can do a few things. We can remove bad data, replace data with some predefined value, change the format of data, such as changing a number to a string for classification, like you see happen a lot in zip codes. And there are many tools available for this. We're going to concentrate on regex, or regular expressions. Regex is most often seen in filtering, rules-based limitation on data ingestion, or replacement, as in like find, replace operations. Schema change is a term that data people like to use for changing the structure and type of data. Just on that, schema change is kind of a catch-all term, so technically it fits both clean and shaping. I'm including it here because it's an important concept for awareness. You won't need to completely understand totally what I'm talking about with schema change, but I don't want you to get caught off guard if you do hear it. All right, moving on. Shaping data always involves some combination of data, whether it's bringing two separate data sets together, joining, or performing mathematical operations on data. I'll spend a slide on each of these concepts as well, so let's move on. And finally, we have analysis. Broadly speaking, to analyze data, we either compare, classify, or predict outcomes. Again, there are a lot of options, but we're going to focus on visualizations of histogram and density plot for comparison, logistic regressions and k-mean clustering for classification, and linear and regression splines for nonlinear regression. And combining all of those together, comparison, classification, and predictions, we have some of the most often used models, neural networks and regression trees. Most of our examples are going to focus on the analytics parts, but we do need to consider the data activities and all the other stuff to get the data into a usable form. All of this will likely be relevant to you right away, but first we are going to have our next polling question. Barry, what have we got?
Well, thank you. As you know, you will have about 30 seconds to respond to each of the polling questions today, and you may begin responding to questions as soon as they appear on your screen. Our second polling question is, what is your experience answering business questions with code? A, I've built an app to do it for me. B, code is an everyday activity. C, I code it a few times a month. D, I haven't had the opportunity to code professionally. Or E, I'm not really interested in code. Please be sure to click the Submit button on the right side of your screen, just below the response option, in order to successfully record your answer. Now I will turn the presentation back to Daniel.
Thank you, Barry. And I know I've had quite a bit of experience in coding. I'd be interested in knowing about you or maybe some of the accountants that you've worked with in the past.
Most of it was writing script. So we would, primarily for Excel spreadsheets or for multiple spreadsheets so that we could get the data together. As far as pure coding, back in the day in 1973, I was learning Fortran or one other of the languages, but never did much with it.
Ah, man. Yes, good old VBA to bring Excel sheets together.
Yeah.
Well, let's see what our audience had to say. Let's take a look at our polling question. Looks like I have not had the opportunity to code professionally is far and away the winner. I'm surprised to see about 15% said I'm not really interested in code. That's surprising for this audience. Barry, do you have any thoughts on these results?
I mean, yeah, I'm actually surprised that I'm not really interested. The code isn't higher. I think there's a need to do scripting, but I don't know how much scripting versus coding and what we're talking about there.
Yeah, I think that's actually an excellent point, since to me, code is pretty much anything that you're not interfacing directly with a graphical user interface, but I can see that code would be looked at as like building an application from scratch as well. So that is something for me to remember while I'm going through these. That's why I asked these questions in the first place. Fantastic. All right, well, I will move on now and add a little bit more insight for you guys. So let's take a look at connecting, cleaning, shaping, and analyzing data. And we're going to start with connecting to data here in the upper left of the slide with JDBC, ODBC. If you're familiar with connecting to data sources at all, it's likely been through an ODBC or JDBC. ODBC, or Open Database Connection, is typically a standalone application operating on this, is achieved through a standalone application operating on the same computer as whatever it is that you're trying to connect the database to. All of you probably have an ODBC connection manager on your computer if you search for it. JDBC is Java Database Connection. It's a lighter weight connection protocol typically directly used by the process connecting to the database. So if you have like a database connection in Tableau that's specific to a type of database or data source, that's usually JDBC. Both of them translate commands by the requesting application, that is Excel, Tableau, R, etc., into the database language for a given ODBC JDBC connector. So next time, before requesting a file from a SQL developer, see if they can give you access to connect directly to the data or a more structured view, so you no longer have to continue to make ongoing requests. Next point would for RESTful services. I've talked mostly about connecting directly to databases. However, you can also make a connection to an online data source, typically by a call to a RESTful API. This is just a URL with some additional information on it that tells the application what type of data you want. A great example is Edgar, EDGAR. That's the SEC filing database. They provide an API to automatically pull XBRL SEC filings, and a lot of different applications like R has a package to access it. All that's completely free. I will caution you, this is not a good place to start if you're unfamiliar with using RESTful APIs, because the documentation is not exactly easy to decipher. On the other hand, Quandl, QANDL.com, is probably a better place if you want to get started using APIs to pull data. Your city may also have a Socrata or other open data portal API. That's a great way to become more involved in your community as well as get better at retrieving data. I ran through this quickly, so if you'd like any of those links, feel free to email me or shoot me a question in the QA. And then the last bullet on the left there, last type of connection is the easiest, connecting to a flat file. Flat file is what we call a CSV or comma separated value, a delimited file, basically any data set that's arranged in rows or columns, that is a table. Quick warning for those of you planning on using something like R or Python for this, Excel is not a flat file, it's a binary file. You will probably have a hard time connecting directly to an Excel document. Export it as a CSV first. Make sure there's no blank rows at the top. You'll have a much easier time getting started. Now, I will raise this again. Why would we want to connect to a separate file when we could just do all the transformation and cleaning in Excel? The biggest reason comes back to governance. If you're copying and pasting data into Excel, from some flat file source or even a database source, you've created two separate data sets. If somebody tries to repeat your analysis, it's very hard to audit that or reproduce it from the source. But more on that in our governance section. So let's move on to the upper right-hand bullet, and we'll talk a little bit about schemas. As I mentioned, schema is a catch-all term data folks use to describe the structure of data. You'll hear database admins, DBAs, complain about schema changes as they spend a lot of time making processes that assume a specific schema. So that if that schema changes, in other words, someone removes a column from a database table, it could have unforeseen consequences on older applications that also use the same table. Then moving on for our final bullet there, one of the most powerful tools in data cleaning is regex, or regular expressions, a standardized symbolic language. But regex is so powerful, I am going to have a slide dedicated to it. And that's because it's used in almost every platform, with the notable exception of Microsoft Office Suite, but there's simple ways around that. And once you know that it's an option, you will find ways to use it everywhere. In fact, as Randall Munroe of XKCD shows in one of his more recognizable comics, regular expressions can make you a hero. Think about how much time you'll save when you can find literally anything in a giant pile of files. In fact, I'm kind of surprised regex isn't listed in any of the fraud or audit certifications that I've come across, but please someone correct me if I'm wrong, because if nothing else, it would give you a huge advantage if you are in or looking at a job in fraud or audit. And again, so apart from MS Office, it's present in most applications, definitely Python or R. And I mentioned some ways to get around the MS Office limitation as well. So let me give you an applied example. Let's say I had a whole lot of Word or Excel and/or Excel files to analyze. Say I needed to find every instance of US dollars that were not rounded to 2 decimal places. And I needed to get the files back that had this instance in it. We have hundreds and hundreds of files. Presumably they'd all be in a shared drive, so at least I could access them in one place, or a data warehouse. So I'd write a data lake. So I'd write a script that would loop through all the files in that shared directory, and then I'd have them exported as HTML. So not only would I be able to use whatever regex solution I wanted, but the HTML tags would give additional information around the context of the text that I found, and then I could just re-import them back into what they were before. Now, that may sound very complicated, but because regex syntax is almost universal, I can look up whatever regex syntax I'm looking for online, as in what I looked up to answer that question on Stack Overflow. This is what you would use in Excel to find a line that started with a $sign, or the line that did not start with a $sign, have a series of numbers followed by a period, 2 numbers, and then end. That question mark, exclamation point is the inverse of what I have. And yes, that does seem complicated, but if you can read that line, you can do about 80% of regex. And again, you don't really need to learn it. You just need to know it exists and how you can use it. The actual syntax is something you look up online. Seriously, nobody memorizes everything in regex, and whatever it is that you're trying to ask, just Google it. I'm 100% certain you're not the first person to ask what it is you're trying to answer. It'll be on Stack Overflow. I'm 99% confident. Now, on to SQL. All right. When we shape data, frequently involves bringing several data sets together. This is a great example from what Barry was talking about earlier. Most of the time, that involves performing joins. A join adds data from a new table into an existing table, given some matching criteria between the two tables. The purpose in most cases is to add additional data other than what we were using to match. For example, I can join a table of sales and return product returns by day or date. I can also do something like unemployment and population metrics by state. There are generally a few types of joins, different types of joins. There's a left join. Left join only adds records from a new table that fit the matching criteria to the original data set. If an existing record does not have a match to the new data, nothing is added or removed. Inner join returns only records from both tables that match. A right join is the same as a left join, but only includes all records from the added table and excludes non-matching ones from the original. And an outer join is all the records with empty spaces on both original and added tables. Now, that seems complicated just looking at some Venn diagrams, but you guys use left joins all the time. They are the same thing as VLOOKUPs, at least very, very close. And in my personal opinion, they are even easier in SQL. Let's look at an example. Say we have two tables, table 1, table 2, and we want to add column C from table 2 to table 1, where values in column A in table 1 match values in column A from table 2. So you see values in column A. In both of those tables, some of those match. We want the matching ones to be in column C in table 1. This is a very common occurrence in Excel, right? We use VLOOKUP to solve this. But the thing is, VLOOKUP syntax doesn't make that much sense when you read it out of context. Even if I had used table notation and had named the exact columns that I was referencing, there's still a relative reference to, so I don't know which column that was, and false just randomly stuck on the end there that is saying that exact match only. I don't know why that's an option in Excel. I've never used anything but false in a VLOOKUP. So contrast to SQL. Now, SQL reads like a sentence. I want to select columns A, B, and C from Table 1, left join, now that we know what joins are, Table 2 on Table 1, column A equals Table 2, column A. And both codes produce the same output, but the SQL is much more transparent and can easily be edited if needed, as well as audited, translated, etc., etc. All right? Now, that's not the only similarity between SQL and Excel. Look at aggregations and pivot tables. So, as you learn more about data science tools, again, you'll find that many of our data cleaning and shaping operations are based on SQL. Or we spend a lot of time getting data into a form where we can use SQL-like code syntax. So learning basic SQL is a great way to do a lot with data science as well as data. And one of the most common operations in data analysis and operations are aggregations, such as summing a column of values or getting the average. And most of you already know the basics here too. So again, not exaggerating. Books and courses start teaching you a bunch of theory or give complicated examples about SQL, whatever. Allow me to give you just a very simple example to give you some confidence that you might know more than you think. Basic aggregation is similar to pivot tables. And honestly, complex aggregation is probably easier in SQL than trying to do anything complicated in pivot tables, but back to basics here. So let's look at a very simple data table. Now, in the interest of space, I only have 3 rows, but use your imagination that there's like hundreds of these rows, okay? I want to get the sum of column B, right, column B, by the names in column A, where column C is either cat or dog. Now let's look at the SQL. Again, it reads like a sentence. Select column A, sum column B from data table where column C equals cat or column C equals dog, and group that output by column A. All right? While if I try to show you what I did on a pivot table, all I can show you is this box. There's not even an easy way for me to show you the filtering rules. But trust me, they return the same data set. And pivot tables do exactly the same thing as SQL aggregation. Let's look even more closely at the similarities. So group by. This is how you indicate the column containing values that you want to aggregate. It's just like selecting rows in a pivot table. You only need to make sure you include the column or columns in both the select and group by clauses in your SQL. Aggregations, sum, average, etc. The same aggregations you use in Excel, you can use in SQL. But now you can read them and edit them easily. And finally, although not an aggregation, a quick note, where in SQL is how you filter. This is much more flexible and transparent than filtering in a pivot table, which requires clicking a bunch of boxes and hoping Excel interprets it correctly. And finally, as a quick note, please do not use the operation pivot in SQL if you are just learning. All right, if you Google pivot in SQL, you will get documentation on some very complicated stuff, and it will make you never want to do SQL. All right, that's how pivot in SQL is how you make columns out of data. You don't need to do that most of the time. All right, just keep it with your select columns, sum, aggregations, and group by, and then you can figure out pivot later. All right. I don't want you to get scared off when you see that documentation for pivot in SQL because it's a completely different thing. All right. Moving on, let's get to visualizations and our comparisons in analysis. So we oftentimes use visualizations to compare and identify trends. But I'm not here to describe basic visualizations. You guys know about those. I'm going to show some of the lesser used visuals. but they are better served to show complex relationships and patterns. So first, we have histograms and density charts. Both represent the frequency of occurrence of a particular numeric value. A histogram aggregates the count of values on the y-axis by a binning of analyzed values on the x. What do I mean by binning? Binning is basically a group by some range of numbers and a count of records containing a number in each range. It's a frequency distribution. Density charts show the percentage of values that make up the total frequency. Each graph in a frequency plot adds up to 100%, and both can be separated by other factors to see if patterns are created. It's a great way to analyze the influence of some other factor on another. You'll see a few more examples of these later, but look at them as a bar chart of counts by whatever that value is. We often use scatter plots and 3D scatter plots to explore trends over time and to see more complex patterns. I'm not going to go too in-depth on these visuals in this presentation, but know there are easy-to-use packages in R and Python and other platforms to make them. Now, a bit on visualization best practices. 1, avoid pie charts. All right, they don't communicate much, really. Think about how a stacked bar chart can better communicate your intended message or some other visual. Since you're looking at, typically use a pie chart to communicate the proportion of something, it's comparing to another pie chart. Stacked bars are much more effective at doing that, or any other number of things. If you want to know what those visuals are, you can reference Cleveland. There's a famous research paper by William Cleveland and Robert McGill all the way back in 1984 called Graphical Perception, Theory, Experimentation, and Application of the Development of Graphical Methods. There's a link to this later. That research paper laid the foundation for modern visualization best practices. They explain how humans can better understand the differences between bars and dots, lines versus angles, size versus color, etc. It's a lot more approachable research paper than some of the stuff that Tufte did before. And most importantly, do not start coding or doing any type of scripting, whatever exercise you want to call it, by trying to make visualizations. Visuals are hard to code. That's why Power BI, Tableau, other reporting platforms like NetSuite, all these exist. Because for code, in many cases, you have to shape the data first to make the visual you want, or it's an output of some other coded process. So that means you have to have other prior knowledge before getting to the visual. This makes people feel like coding is very complicated and they have no idea what they're doing. So concern yourself with shaping, cleaning, and more advanced analytics and code, and leave visualizations to the tools. Speaking of complex analysis and built-in visualizations, what data scientists often use for exploratory analysis, since we have so much data and are usually built in outputs, regression trees. So the regression and classification trees are great examples since they can do a whole bunch of comparisons at once, then tell you what's the most meaningful or a given outcome. But a lot more on those in a minute. So first, let's talk about exactly what do I mean by regression and classification. Regression. Regression is when we attempt to predict some type of continuous outcome value using other values. Regression models are typically used in financial forecast, econometric models, and other attempts to better predict and understand activity measured in dollars or units. In order to construct an optimal model, we construct some form of linear or nonlinear function that minimizes error between the predicted and actual values. The difference between linear and nonlinear regression is that linear has one continuous function, and nonlinear may have several different linear functions or do something else entirely, like a series of tensors in a given vector dimensional space. But to keep things simple, one of the better nonlinear models I've used is Mars, or Earth in R, which uses adjustable regression splines to combine multiple linear models into a single function. Classification. Classification models predict and or cluster discrete values. They may be used to predict outcomes such as buy, click, like, read, vote, etc. Other classification models are used to cluster or group large amounts of data into more manageable groups. Customer personas, risk tranching, these are applications of clustering. And to add to our confusion, Regression models are often used in classification, but they include a linkage function to transform the linear outcome into a discrete outcome. Easy, right? All right. For example, logistic regression outputs a linear function S-curve, but is used to predict a binary read 1 or 0 output. So, as in the example on the screen, if x is greater than 0, then the function would return 1. If less, it would return 0. And clustering may also use regression, but it'll fit a line or lines that classify items differently depending on which side of the line or lines they exist. All right, so that was nice and complicated, right? Simple, you guys are smart. So let's get even harder, as I'm now going to talk about neural networks, but they're not actually as bad as you think. So in an actual oversimplification, neural networks are just a bunch of logistic regression bundled together. Now, that sounds complicated, but a neural network takes in thousands of 1 or 0, true or false encoded inputs that will or will not activate a bunch of weighted inputs assigned to a bunch of other models. These models output 1, 0, true or false, to activate or not more weighted inputs to more models, and so on until a terminal output. Now, I'm not going to go any further in depth on neural network models. That can be a whole presentation itself, but they really are not as complicated as they sound, at least at this level. I encourage you guys to take a screenshot of this slide and work through the math of the blue versus gray numbers, and you should be able to get a better understanding of how information flows through this neural network. All right, and finally, one of the easier to learn data science modeling techniques. Trees are often the first model taught in data science courses, and they can be an effective way to start incorporating data science into an organization. This is because they are easy to execute, interpret, and apply. You can input tons and tons and tons of potential inputs, and the tree will sort through them and pick what factors are most important, stick them higher on a tree for a given set of outcomes. For example, even without knowing anything about this data, on the screen we see the blue box at the top. 100% of our sample has a mean value of 4.6. If we move left, those who have a location code of rural, moving left of the tree, we see that those who have a location code of rural or urban, 37%, have a value of 2.4. And then if we move left again, those who are only rural, 19%, the 19% in that tiny blue box on the far left of the bottom left of the tree, has a value of 1.2. You don't need to know anything about what I described, what I had predicted, inputs, etc., but you understood those rules. Now, that's how easy these visualizations are. Of course, I'm not going to leave it there. In the next module, I will show you how I built this visual, as well as density plots and demonstrate the overall workflow of data science. But now let's catch our breath really quick with another polling question. Barry, take it away. Oops.
Thank you.
Now, take it away.
Oh, thank you. As you know, you may begin responding as I read this question. Our third polling question is, which of the following best describes why you want to learn about applying data science? A, data science is the future of management accounting. B, enabling data science is the future of management accounting. C, I want to increase my marketable skills and employability. D, I want to make my life easier with automation and code. And E, other. Please note that after selecting an answer, you must click the Submit button, which is located on the right side of your screen, just below the response option, in order to successfully record your answer. Now I'm going to turn the presentation back to Daniel.
Thank you, Barry. And I'm just thinking that the next module explains how to actually use this stuff. I should have probably asked this question after that one, because I may have just scared everybody away from data science without giving more info. What are your thoughts on this question? So.
I think knowing how to manipulate, use, and access, manage the data will be the future of management accountants. A lot of the processes that we currently do can be done by either AI, other types of processes. So we're moving in towards more analytical needs within the management accounting field.
I agree. And let's see what everybody else thinks. Let's see. Enabling data science, true data science. Okay. All right. Thank goodness. I was really worried I'd see a lot of others on there. So it looks like data science and enabling data science is the future of management accountants, and as well as increasing skill. This is right down the, this is almost evenly distributed. So I'm glad we have an interested and diverse audience.
Yeah, and the fact that they're all, centered around the use of automation is a positive sign.
Mm-hmm. I agree. All right, so let's get into the application of this stuff. How can we help determine the activities that can make all of our lives easier with data science and maybe get some access to training? Now we're going to focus on how we can use those tools that we talked about in Module 2 to help ourselves and outline what type of training we may need. And as I'm working through these examples, please be sure to take notes on certain concepts you may find helpful. Include the code package or library in your notes. Refer to the concepts introduced in Module 2 so you'll know what you need to learn more about in your training. This is still going to be fast. Remember, this is just for recognition, not for full learning, but I will do my best to dive into things that I think are very important. So for your core competencies, and while I hope my examples and concepts are relevant to most of you, I do understand everyone is different. The IMA is producing a competency framework in the area of data and analytics to give you a more comprehensive set of guidelines for all management accountants. I encourage all of you to keep yourselves connected to the IMA, review upcoming articles in strategic finance. I have one coming soon with Rafe for more information. Also the TSP link up blogs. Barry and I are both an active part of TSP, Technology Service and Practices Committee. That's another great source of information. Don't forget to read and comment if there's a concept you're interested in or having trouble understanding. So with that being said, we've covered a lot. So let's review it very quickly. I like to reinforce knowledge. What we've seen so far, we always want to connect to data. That may be direct to a database with ODBC, JDBC, maybe using a RESTful service like Quandl, or to an external file. We do not want to copy paste our data because it impacts governance process. Excuse me. We clean our data with code to ensure a consistent and transparent schema so we can reuse both the code output and the data itself. Regular expressions are a great way to standardize our data transformations and filtering rules, allowing them to be used in other business applications. You do not want to do manual find replace. That's near impossible to audit. And you will not be able to, quote, look at all the data. It's way too big. But I will show you how to look at the first few records, and that's all you really need. We shape our data by merging or joining separate data sources together and aggregate using functions. If you can understand VLOOKUP, you can understand joins. If you can understand pivot tables, you can understand basic query aggregations. And to reinforce, the real efficiency in using code is its reusability, and the only real way to make your code reusable is by connecting your application to your data instead of doing everything inside a single application. And by application in this case, I mean like R or Python or whatever. You would be writing code in that, not writing an entire application. We use analytics to predict, classify, and compare. Predictive models are not always high mathematics. We can use them to identify and better understand what influences other types of outcomes. Many of these have built-in visualizations to help with communicating results, such as data mining tools, regression, and classification trees. And now, let's come back to that earlier example of a data scientist in an insurance agency so I can show you how you would mine data using trees and other tools. So, in this example, and it's been a long time since I introduced the scenario, I barely remember it myself, our background is that we are an insurance provider, an online insurance provider, and our potential customers apply through our online portal. Depending on what they enter, our model classifies them as high risk or not. And in this example, it seems that we are receiving some higher cost claims than we expected. And now we need to determine if some other rules need to be applied to our high risk rules. potentially increasing premiums for some group of customers. In this scenario, we are only able to receive a regular file output from our data stakeholders, which is not an uncommon scenario where highly sensitive information may be contained in the database. They do like to control that. And in this example, we will be using R to accomplish the analysis. I will show you the connect, clean, shape, analyze process as it exists in real life. As I mentioned, it's not always linear. Sometimes we go back and clean and shape many times. Again, all the more reason why transparent, reusable code is so important. First we'll connect, then as we get into our cycle, we'll visualize data for patterns, outliers, get an understanding of our data, clean by filtering if needed, and shape data through normalizing claim amounts as a proportion of monthly premium amount paid. However, before I dive in, I want to show you how I'm creating the visualizations in this presentation, because I'm sure that's something that you guys are going to ask me. For this presentation, I created everything in R, using RStudio as my development environment. I selected R plus RStudio because it's one of the easiest platforms for someone who's using their own laptop or desktop to get started with, and R has great integration with many existing BI platforms. R is completely free and open source. There is no charge for R ever. Do not pay for it for personal use. RStudio Desktop is also free and open source, so you can download and use the community version and use it for personal use. I have to say, notice I did not say commercial use. Before using R in a commercial environment, you must verify with your organization that is okay. All right, yes, verify with your organization before you download and start using R. All right, I did not tell you to use that. Okay. Yeah, use it for personal exploration all you want. Make sure your organization's okay with it. All right, with that out of the way, you will see links at the top of the presentation in the upper left-hand corner to download R and RStudio. Please remember you will need to download both. R is the code engine. RStudio is just an easy way to interface with R. I'm using File, New, Type, Notebook, so my analysis is contained in one page, and I can export it to a report later for validation and audit, even export it to an HTML file and make a web page. I am able, using the notebook format, I'm able to write blocks of code, those little gray bars where it's pointing to say create blocks of code, and then I can run them in chunks to create the visualizations that you see in the presentation. I see all the tables and variables that I've created there in the upper right-hand corner, and if I get really lost, there is a help section in the lower right. If you want to know more, feel free to drop a question in the QA. All right. So first, connect. We want to connect and explore that raw data file that we received and produce some visualizations and some analysis. And remember when I spent all that time talking about the importance of connecting to data and keeping it external? This one little line of code is all you need to type to connect to data. Consider how much time you've had to spend explaining how to copy-paste data just right into some Excel template you made, and how much work you spent locking it down so people couldn't edit the wrong thing, and how they always found a way to edit the wrong thing anyway. This one line of code right here was all that was standing in your way. Read.csv. The read.csv function creates a type of data object, a data variable, called a data frame. In our case, named data. See that? Arrow into data. Data frame is just like a table in SQL or Excel. It's columns of different types of data arranged in rows. Imagine a spreadsheet table, but one you can interact with in code rather than pointing and clicking. And if you were worried about not seeing the data once you have your file assigned to the data variable, all you have to do is request to see the head, aka first few lines of your data. Head also shows us the column name, their data type, that's in little tiny gray letters below the column title, you probably can't see them, and how many total columns. You can see our data frame contains 24 columns, that is variables for our model, and all of this with only 2 lines of code. Pretty good so far. But let's move on to visualization so I can show you what remains easy and not so much. All right, so let's attempt to visualize our data now. First, we're going to make some histograms since that, and we're going to look at claim amounts, and that's probably the most important feature. All right, to do this, we load a package, ggplot, from our library of packages. Packages, sometimes called libraries in R, these are pre-built code collections that extend the functionality of R. Understanding what package to use and when is a crucial step to doing analysis in R or any analytics language, really. So by using the package ggplot, I can make a histogram fairly easily. We will need to retrieve the total claim amount from our data frame, and in the example here, you see that the variable total.claimAmount column, I only need to type data $total.claim.amount, and that gets me that column from the data frame. However, even now, some of this isn't necessarily that intuitive, such as I'm using qplot as the function and not ggplot. Like I said, visualizations are weird in these things. But once we understand the basics, we can see how the code may be reused. And even if you don't remember all the details, you can just copy and paste code like I have here and to a working function and modify it slightly, such as if we want to create a different visualization, one of income. So I just copy and paste it and then change the total.claim.amount to income at the end of data, and now voila, I have a visualization of income. And you see this weird huge spike at 0 income. So we have a lot of our customers with 0 income. So we can extend this function further and just add a parameter of fill, and we have another variable fill that says employment. So now our visualization is colored by employment. Right? Oh, look at that. All the people with 0 income were unemployed. That seems kind of obvious now that I think about it. And you may be thinking, seeing these examples, that yeah, that seems hard, but not that hard. Why am I making such a big deal about not starting with visualizations? Because it's not really the visualizations themselves. The out-of-the-box ones are pretty easy to make. It's hard when you get into formatting. You'll quickly descend into madness if you try to make sense of visualizing this much data, let alone trying to format the darn stuff. And who knows what's going on in that code. This is a code visualization I've used a few times with fewer variables, but I always have to look up the syntax for it all the time. So I would keep using reporting and visualization tools for now, particularly those of you that said you weren't interested in code. But you can use R and other analytics languages for much more powerful analysis of complex data, like regression trees. All right, so how do we actually do some data mining in here? And you can see a more complex analysis, the code is a lot easier to understand. See, this has a lot more inputs than that nonsense from the previous page, and I can walk you down through that gray block of code line by line. Again, we import some packages. In this one, it's rpart and rpart plot. We define a formula saying our columns, total claim amount, tilde, then whatever columns we want to evaluate. We can have a bunch. It's only going to show you the ones that are important. And then it performs a huge analysis against that function to determine what are the relevant factors, which one creates more separation, and which ones are more important by sticking them at the top of the tree. The package rpart.tree already gives us great default formatting, so we don't have to worry too much about the visualization. I can tell you, though, if you start trying to mess with this formatting, you're not going to have a good time. It's really confusing. So stick with the default output. This visual shows us location, that location and employment status is a big factor in claim amount. That's the upper left and lower middle of the tree, respectively. But we also see coverage type coming out. And of course, we would expect people who have higher coverage tiers to have higher claim amounts. That's why they buy higher coverage tiers in the first place and why they're charged more for their coverage. Okay? Now at this point, we're getting into some interesting details. It's a great opportunity to show visualizations, cleaning, aggregating, analysis operate as cycles. So I'm going to spend a few minutes going through a more real-life data science analysis. Right? So we continue to clean and shape our data. And as we saw in the previous slide, the coverage tier was shown to impact total claim amount. We also saw location code as another impact. And you can clearly see the separation in the density plots below. The first one shows our claim amount by the coverage tier, and then the second one shows the claim amount by region. All right, so we need to control for claim amount to coverage. The original business question was about profitability, so claim amount relative to the premium amount, or how much they were paying in versus how much they were getting out. As a rough control, we can divide the total claim amount by monthly premium, right? And that's actually really easy to do in R. It's tiny here in script, but all it's saying is divide this column by that column and create a new column with $ my new column name into my data frame. Now, our density plot shows almost perfectly similar distribution between coverage type and claim to premium. Awesome. But there is a bit of separation in location code, even more. And what's with that weird bump in the suburban folks? Well, instead of going through a bunch of visualizations again, now we can go ahead and do a tree. And we can get to the bottom of it. We evaluate coverage, education, employment, gender, income, marital status, et cetera, and, well, first off, we see that our model does not show any impact for coverage type, so we have control for that, yay, and we see new predictors bubble up too, marital status and income. And speaking of income, another great benefit of tree models, when numeric values are used as predictors, the model will sit there and make a whole bunch of different splits and see if a pattern emerges in the outcome versus a higher or lower split in that value. And in this case, we see that the model found suburban, so moving to the right there, single members with an income less than $5,138 had a much higher claimed premium than other groups. That's almost 7 times higher than the lower group, rural, over here on the far left. Now, I hope that example was relevant to you, and I'm sure there are a whole bunch of other things we could look at and things that I jumped over in the analysis, like region, etc. And if any of you are asking those questions right now, and I haven't looked into Q&A, and I imagine there's some of them about what I did or didn't do, that is fantastic. That means you guys have an inquisitive mind and you are already basically a data scientist. So congratulations if that irritated you. Welcome to the club. Okay, last but not least, in L3 are learning resources. So let's work on getting those technical skills if you want to train yourself or team to be data scientist, enable data scientist, etc. The primary source will be the resources I mentioned through IMA, core competency training regimens. Those are coming soon in strategic finance. Regex is something, again, you'll never completely memorize. Just know it exists, Google what you're trying to do, and then use a tool like Regex 101 to test your solution. Visualizations, refer to Cleveland, go from there. SQL, Khan Academy probably has the easiest way to get started. Then you can use a more in-depth online course. And R Studio have a ton of resources on their site. They do go into some linear algebra stuff. You can safely gloss over that unless you want to be a like official superstar data scientist. But for most of you, just the basics of how to manipulate data frames and create reproducible reports in R Markdown should be sufficient. Whew, that was a lot. Now, let's have a survey question to take a little break, shall we? Barry, take it away,
Thank
sir.
You. Oh, you're welcome. Thank you. Our fourth poll question for today is, what aspect of applying data science, which we have covered, would you like to learn more about in future presentations? A, connecting to data online with RESTful services, for example, Fred or Edgar. B, data cleaning with regex. C, mathematics of classification and regression models. D, neural networks and artificial intelligence. E, visualization. Please note that after selecting an answer, you must click the Submit button, which is located on the right side of your screen, just below the response options, in order to successfully record your answer. Now I'm going to turn the presentation back to Daniel.
All right, thank you very much, Barry. And I'm just a few minutes over time, and I want to leave time to answer questions at the end. So I'm going to speed up these the polling questions. But I would like to hear at least your thoughts on the aspect of data science you would like to learn more about in future presentations.
I think visualization and neural networks and AI.
Wow, yeah, I like that too. Yeah, neural networks would be fun. I think, yeah, there's a lot of opportunity there for us to learn a little more about enabling artificial intelligence. Let's see what the folks thought on our end. Interesting. It's all in visualizations and then combinations of neural networks and AI. I will say that visualizations are nice. There is a bit of a problem with visualizations in that they do rely on human decisions as soon as you have a person interface. But in the near term, yes, visualizations are very cool, albeit not particularly easy to code for. And I'm just going to move on, sorry, Barry, so that I can cover the bit on governance, because that is a really relevant topic. All right. So how can effective data governance enable data science? All right. Let's compare data science and data governance first. Okay. So data governance is about stability and reusability. Data science is fail fast. Data science is okay with making mistakes. Data governance wants to make sure that data science can explore previous mistakes so they don't make them again. Now, data definitions in data governance, whereas in data science, data is the definition. Data scientists typically don't care what a piece of data means, just if it's significant to their model. That is, until somebody has to use that model. Data governance makes sure somebody knows what that data point means. This helps prevent people not trusting data and improves trust in data science results. Standards versus innovation. Believe it or not, these can coexist as long as everyone knows what is a standard and what is being done outside of standards to see if a new standard can be made. Development versus spot solutions. Data scientists don't like repetition, and they don't do reporting well at all. If the same request is made twice from a data scientist, there's probably a problem. Oops. Which gets me into the automated deployments versus automated results. However, data scientists will still want to launch automated solutions internally for development and POC. Governance provides automated controls on applications and other solutions getting released to enable data science to fail fast with their spot solutions and not break everything. So while it may have seemed that data science and governance are opposites, they can get along very well when data governance is positioned to enable data science. And data science desperately wants data governance. Why? Because what data scientists actually do is clean data. 70% of data science is dealing with data. And accountants are very good at data governance and dealing with data. Does this look familiar on the right-hand side? Look at the dimensions of data from Robert Siner's non-invasive data governance. Those are the attributes of accounting data. The principles are about accountability, rules, and regulation. The principles and dimensions are clearly defined in the policy statement. And now that data is viewed as an asset, accountants are perfectly positioned to assume data governance policy, particularly one that enables rather than constrains business. And governance isn't hard. It's really helpful. Let me give you an example of some simple governance concepts that you can put in place right away. So here's an example of a flat file analysis, what we've already seen. The business user makes a request to the data scientist makes a request for data from the SQL dev, the dev writes a script, that script produces a file extract. Now, in order to verify that the extract is the same, there'll be a hash validation. I'll talk more about that in a moment. The data scientist produces an R script, and that report goes to the business user. So where are the levels of governance in place here? Now, first we have version control. Version control, and its most popular version control tool is Git. It's a managed platform called GitHub for storing and sharing repositories of code. Version control is a broad term for the ability to manage changes. This is not putting V1, V2 after a PowerPoint presentation. This is a way that we can have many different people working on a file at the same time, then merge those changes together. At any time, you can roll back to a previous version of a file. Look up Git, look up version control. There's probably a lot of great ways that it can help your workflow. Hash validation. Have you ever downloaded an open source application and saw a bunch of weird numbers and letters next to it? That was probably a hash, and it's an easy way to make sure the file you downloaded was actually the file originally uploaded by the website, because even the smallest change in the file completely changes the hash value. It's a way to prevent man-in-the-middle attacks during the download. It's also a great way to verify that the data set hasn't been modified. If the sender runs and saves a hash on the file, anyone who runs the same hash on the file will get the same result, providing clear indication that the data was manipulated if an issue arises with the data set. Now, of course, it's easier to connect the data source, but sometimes that's not possible. And again, likely you will see MD hash used the most often, but there are many more and much more secure options available. Acceptance criteria and requirements. Agile delivery practices include stories and acceptance criteria. Others will just generally use the phase requirement, the phrase, quote, requirements. These can be the format of numbers, KPI calculations, expected results, etc. When the acceptance criteria includes calculations of values, the criteria should be included in the resulting coded solution as a unit test. A unit test gives a great way to automatically include testing, and as code is deployed, you can automatically know if it is correct or not. That way people can discuss the correctness of the unit test and the acceptance criteria rather than the code itself. All right, and on that note, I'm going to turn that over to Barry for our final polling question. Thank you.
Thank you, Dan. Our fifth polling question is, how would you describe how the role of management accountant is changing due to the data-driven economy? A, not at all, and it doesn't need to change. B, becoming more focused on analysis of data. C, becoming more focused on data governance. D, a jack of all trades encompassing data and analytics. Or E, something else entirely. Please note to be sure to click the Submit button after choosing an answer in order to successfully record your answer. Now I'm going to turn the presentation back to Daniel.
All right, thank you very much, Barry. I appreciate that a lot. And so I would like to think, though, how do you feel the role of the management accountant is changing in the data-driven economy?
Well, I think being able to analyze the data is absolutely critical. But unfortunately, I'm not sure the political economy is supporting that, so we'll find out. What does everybody else think?
All right, let's find out. Okay, so it looks like the role of the management accountant is being more focused on the analysis of data or becoming a jack of all trades encompassing data and analytics. I would certainly agree with that. I really like the not at all and it doesn't need to change. That's very good news.
Yeah,
right?
That was the one I was glad to see, way down there at 1%.
Yes, exactly. Well, and all right, and I am just going to move on quickly just to give a short summary of what we've reviewed so far, but I do want to have time at least for one question. So we will say our first learning objective, we learned about how data is created, stored, and moved in an organization. Cycle of activity, integration, transaction, ETL, blah, 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 business decisions. In their second and third objective, we surveyed data science concepts and how they may be useful for your day-to-day activities. For connecting to data, look for a JDBC or BC option. If you receive a flat file, consider connecting to the file instead of copying and pasting. For cleaning data, know that data can come in many types and know that regular expressions are a general tool available for many platforms. Also, you don't need to memorize all rules of regular expressions. Just know enough to look it up when you need it. Most shaping of data is performed using SQL or code syntax similar to SQL. This means you only learn to know the basics of SQL to start shaping data. As you may already know, the concepts, joins, are VLOOKUPs, and aggregations are pivot tables. On analytics, we use visualizations to compare models to categorize and predict. Consider tools like NetSuite, Excel, Tableau for visualizations, and ongoing reporting, actual research, should stay in code for reproducible research. Predictive models can accelerate understanding of data as well as predict outcomes, and R is a great place to start. Python is also great. It's just a little harder to configure your environment and get started. Finally, for governance, we looked at acceptance criteria, version control, and hash validation. Although not exhausted by any means, these concepts are a great start for accountants, and accountants are well suited for governance and analytics. Now, because management accountants have a lot of opportunity in this space, we know how business works, and we can interpret complex results of analysis. We also are uniquely able to enable data science and other data-driven activities through effective governance, while aligning data accountability with data-driven revenue. And with that message of I hope, and optimism, again, thank you all for attending, and I will now turn to our moderator to answer some of your questions. Thank you.
I don't know that I'm going to answer questions, but I'm going to ask a few questions, Daniel. So I'm going to start off with the first one, since one of my particular interests is in data governance. And you mentioned governance can be restrictive to an organization. Can you provide more detail on why that occurs? And
Sure thing, Barry. Yeah, and how data governance can be restrictive is an interesting concept. One of the situations that I've seen in my experience is IT will be tasked with data governance in its entirety. What happens there is that IT is frequently viewed as a cost center in many businesses, whereas the use of the data is actually a revenue driver. When you see a misalignment of accountability versus recognition, problems can occur. As far as IT is concerned in typical budgeting, they experience all the blame if something goes wrong in data governance, but they get none of the credit for enabling it. One of the big reasons why I see accountants playing such a powerful role in that process is we are very good at aligning revenue with activity. So we can help set protocols in place to either align the revenue with the responsibilities of IT or manage the accountability of the data governance practices with the people that are actually using that data to drive revenue.
very good. That helps answer one of my concerns. I'm going to go to another question. Is I'm interested in data science. Is there any online IMA package offered for such?
That is a fascinating question, and I would love to be able to answer that directly. I did mention the competencies framework that's coming out. I am not at liberty to discuss specifics, but there may or may not be something very soon that is a package for data and analytics on accountancy. I do know there will be a great article, I hope, coming out in the next few months in strategic finance that I'm a co-author of that should give you some more insights as well.
So the next question, it seems to me that coding is a necessary skill for management accountants today. Yet very little emphasis is given to it in the continuing education or other forums. What's your take on this?
Yeah, well, as you've seen today, it's not particularly easy to teach any type of coding in a webinar. I hope I gave you some insight, but the real way that you teach coding is through practice. You just answer questions and you work through it. There's plenty of online resources for it. If anybody wants to make any suggestions about how we could create some sort of e-course or online portal or way to help people get hands-on experience with coding, I would love to hear about it, and we could discuss it in some of our TSP committees, or even write additional articles, even articles in strategic finance about some particular coding concept might be helpful for you guys. Just please let me know. I'm open to all feedback.
Yep. One further question. Oh, come on. I'm interested in moving my career towards analytics. How would you recommend that we begin on that? And what sources would you have to help us make that transition?
Well, I listed those links, but generally speaking, moving your career towards anything, the best thing to do is kind of start a portfolio page, since if you usually can't get experience doing it yourself, you can just write articles about whatever it is you're interested in on LinkedIn or any other blogging platform or your own website. You have to do it in your spare time most of the time, unfortunately. But the best thing about data science and analytics is that it's mostly digital. Being mostly digital, you can access it online and place it onto a blog and kind of create your own work experience. Many people that I know that have gotten started that didn't have even an analytics degree or a mathematical degree have become very successful data scientists just because they created their own GitHub account to have code and their own resume page to do their own research projects on stuff they were interested in. That's a big gold star for any potential employers that are looking to hire analyst or data scientist. Plus it gets you better visibility on platforms like LinkedIn for recruiters to talk to you.
Well, at this point, I'm going to turn your attention back to our host, Margaret.
Thank you, Barry. At this time, I'd like to thank our presenter, Daniel Smith, for sharing his knowledge and expertise with us. We're very appreciative that he's made time for IMA and for our audience today. And also, thank you, Barry Nathan, for moderating today's event. We apologize for the issue that many of you experienced with the first poll question today. Please be assured that this will not impact your ability to earn full CPE credit. After the webinar concludes, we will need time to adjust your attendance records to reflect a response to the first poll question. If you have also met the additional requirements for CPE credit and are unable to access your certificate at the end of today's webinar, please click the CPE credit link on the right side of your post-event thank you email that you will receive tomorrow. This link will issue the correct CPE certificate that you earned today, including a response to the first poll question. Again, we apologize for the inconvenience, and we appreciate your patience while we resolve this issue. I want to again thank Oracle NetSuite, our new Tech Talk Mondays title sponsor, and thank all of you for your participation in today's event, your commitment to IMA, and your professional development through IMA's Insight Talk, Tech Talk Mondays webinar series. I look forward to spending time with you again soon when we'll enjoy some more Insight Talk.